Hello, today we'll be solving question number 6 from the RMO 2018 question paper. So in this question, we have been given that let ABC be an acute angle triangle with AB less than AC. And it has been given that let I be the incenter of the triangle ABC and let D, E, F be the points at which its incircle touches the sides BC, CA and AB respectively. Let BI, CI meet the line EF at Y and X respectively. Further, assume that both X and Y are outside the triangle ABC. We need to prove that BCYX are concyclic and I is also the incenter of the triangle DYX. So this is what we need to do. So we have ABC as has been shown in the figure. I have drawn this figure. It's it looks very crude, but nevertheless it will serve the purpose. So we have the triangle ABC, which is an acute angle triangle, and we have AB is less than AC as shown in the figure. Now I is the incenter of the triangle ABC, and D, E and F are the points at which its incircle touches the sides BC, CA and AB respectively. Now this BI and this CI meet the line EF. When the line EF is extrapolated, it meets the line EF at the points Y and X respectively. So that implies, and it has been assumed, it has also been shown in the figure that X and Y are outside the triangle ABC. So now we need to prove that B, C, Y and X are concyclic and I is the incenter of the triangle DYX. So DYX, if we draw on the triangle, let me use some separate color for this. So DYX will be basically so this will be the triangle DYX. Okay, so now let's proceed with the problem. So before starting on the problem, let us find out now the value of the angle BIC. So BIC is basically, we can say it can be written as angle BID plus angle CID. Now angle BID, as you can see, if you can go in the triangle BID, so this will be 90 degree minus B by 2. So this will be 90 degree minus B by 2. And CID will be also similarly 90 degree minus C by 2. So this will be 180 degree minus A plus B by 2. Now this will be 180 degree, A plus B we can write as 180 degree minus C by 2. So this will be, again we can write it down as 90 minus or plus 90 plus C by 2. Oh, this is B plus C, sorry, I have mistaken over here. This will be B comma C, so this will be 180 degree minus A, so ultimately it will be 190 plus A by 2. So this is the mistake I committed. It will be 90 plus U by 2. Let me rub it off and write it in a much clearer manner. So this will be 180 degree minus B plus C by 2. So this will be 180 minus A by 2, and this will be ultimately 90 plus A by 2. Okay, so now we will be proceeding. So now, and also we'll take another thing, we'll assume another thing, that let BY and AC intersect at the point P as has been shown in the figure. So therefore now if we find out angle IPC, now if we find out the measure of the angle IPC, so this IPC will be basically equal to 180 degree minus angle PIC minus angle PCI. Okay, so 180 degree minus PIC will be basically angle BIC. Okay, minus PCI. Now BIC we have already found out there is 90 plus A by 2, and PCI we know that this is equal to minus C by 2. Okay, so therefore this is the value, and this angle IPC is equal to the angle EPI. Angle IPC is equal to the angle EPY, since vertically opposite angles. Okay, so that implies that angle EPY is also equal to 90 plus A by 2 minus C by 2. Okay, so this is the structure that we are getting. So now we'll try to find out, we are trying to basically find out the value of the angle EYP. So okay, if this angle EYP is also equal to C by 2, then we can show that the entire BCYX is a concyclic triangle. So that is our aim, or what we are trying to accomplish. So we have found out one angle EPY. So now we need to find out the measurement of the angle PEY. So for PEY, what we'll try to do, we'll find out the angle AEF. Now this angle AEF, as you can see, this will be equal to 90. Now 90 minus A by 2. This will be equal to 90 minus A by 2. And this is equal to angle PEY, since vertically opposite angles will again apply over here. So we have found out PEY and EPY. So in triangle, now if we consider the triangle EPY, implies that angle EYP will be equal to angle basically 180 degree minus angle EPY minus angle PEY. So this will be 180 degree minus EPY will be basically 90 minus A by 2 plus C by 2, and PEI will be again 90 plus A by 2. So 180 cancels out, minus A by 2 plus A by 2 cancels out, and we are ultimately left with that angle EYP is equal to C by 2. Now this angle EYP, now angle EYP is basically nothing but the angle BYX. So angle BYX is equal to C by 2, and angle BCX is also equal to C by 2. So we have therefore now EYP is nothing but angle BYX, okay, C by 2. Also we have angle BCX is equal to angle C by 2. So since these two angles are equal, so we can therefore write that BCYX. Also similarly we could have shown that angle CXY is equal to angle CBY, and both of them are equal to B by 2. That also we could have shown. So by this example, by the process that we followed, we can show that BCYX are all concyclic. Okay, so this is the structure. So now this is what we have got. The first part of the problem is solved. Now we'll move forward to the next part. So the next part is that what we'll try to do is that if you consider, let us find out the value of the side BY. So BY, if you go to the figure, so BY will be equal to, we have basically BI then IY. Okay, so this will be BI plus IY. Okay, so this will now BI, if we use the sine rule, so this will be equal to ID upon sine of B by 2. Okay, and IY we can write it down as, if we go to IY, so IY can be written as, if we consider the triangle IEY, then IY will be equal to IE into sine of A by 2, sine of A by 2, since this is the angle we are getting over here, this angle is basically 9 by 2, by sine of C by 2. So ultimately the structure that we will be getting is that ID by sine B by 2 plus IE sine of A by 2 upon sine of C by 2. This is the structure we are getting. Now we know that ID, IE and IF will be basically the radius of the incircle, so they are all equal. So we can write that IE, we can write it down as ID. Okay, so now if we take ID common, and ultimately if we break the structures and apply the regular formula, so this will be ID cos of B by 2. So BY will be ID cos B by 2. So if BY is ID cos B by 2, so now if we go back to the triangle, so we have got over here that BY is equal to ID cos of B by 2. So this is B by 2, and we have ID over here, and then we have BY over here. Okay, so that will imply us, so if we insert another page over here, so since we have that BY is equal to ID cos of B by 2, so that implies that angle IYC will be equal to 90 degree. And if angle IYC is equal to 90 degree, so that implies that IDCY is concyclic. And if IDCY is concyclic, so that will imply us that angle IYD. I suggest that you keep the diagram close to you so that you can understand what I'm trying to get over here. So please draw the diagram at first in your copy, and then as I proceed with the problem, you carry along with that. So we get angle I by D will be equal to angle ICD, and that will be equal to C by 2. And this is because we can say by the angle by the chord. If we consider the chord basically ID, then we can get this thing. And using the similar process, similarly we could have also shown that IDBX is also concyclic. If this is also concyclic, then it implies that IXT will be equal to angle IBD, and both of them would have been equal to B by 2. So that implies that if we basically take this as the equation 2 and this as the equation 1, then 1 and 2 will imply that I is the incenter of the triangle DYX. Okay, so this is what we are getting so far. So we have proved that BCYX is concyclic, and also that I is the incenter of the triangle DYX. So this is the process that you need to follow to solve the question number 6 from the INMO 2018 question paper. We will be solving the next questions in the subsequent, or if you have any doubt regarding the same, you can comment in the comment section below and we'll try to get back to you. Thank you very much.